Done.
Okay, so I would recommend that everyone is muting the microphone so that there is no interactions while I'm explaining. So welcome everyone to this lecture on advanced energetics. So before we start, I would like to say that so we are going to make a lot of lectures online, but there will be also courses given in presence. So we will try to manage with the student repartition that the PFL is organizing. Unfortunately, it was not possible for us to make an organization in advance. So, but we will profit from the fact that next week there will be no course to make a clear organization with the presence on the campus. Today, the course is online. One of the reasons being that there has been an infection in my group in Sion, meaning that most of my collaborators have to stay in quarantine. It also allows me to remind you that it is very, very important to follow the rules for protecting yourself from the COVID. So the rules, I remind you, is to wash your hands first, to keep the distance with the people, and to wear a mask, mainly to protect your friends from the possible infection that you could carry. So it's very important, and once you have the experience of someone being infected, then you realize that you ask yourself, so if you are infected and if you are going to create burdens to your friends and parents or family. So I think it's very, very important to follow the rules. Okay, so this being said, so I would like to start the course of Advanced Energetics. So my name is François Maréchal. I'm professor here in EPFL. I'm located in the EPFL Valais-Vallis, so in Sion. So it's a special campus that is dedicated to the energy dimension of research, with people working on chemistry and process engineering in my case. So my group is dealing with developing computer-aided decision support for realizing the process and energy systems engineering, so designing energy systems. If you are interested in working with us, we also propose a semester or master projects, so do not hesitate to visit our website where you will find the projects that we are proposing. So this lecture concerns the advanced energetics. So what does it mean? So energetics means the way the energy is used. In our case, it will be in industrial processes mainly. And it's advanced because we would like to show you methods that allows you to identify solutions and propose solutions to solve the problem of energy efficiency and integration of renewable energy sources. So this course will be organized by having a team. So I will be the one who is going to teach, but then Rafael is going to be Rafael Amoedo, who is a PhD in my group, who is going to helping me in organizing the course. So he will be your main contact person if there is problem, if there are questions. He will be the one who will try to make the organization as lean as possible and as smooth as possible. Then there will be 3 PhD students, other PhD students of my group. On the one hand, Xiang, who is a PhD student in my group working on energy systems evaluation. Jonas, who is also for the moment just finishing his master, but he will be also working with us as a PhD student. And Alessio, who is getting an old PhD student, but still there, helping us mainly at the level of the organization. And then we will have two assistants who are former students of my course who are going to help us, Yasmin and Dia, who are finishing their master's studies in mechanical engineering in EPFL. So perhaps I would suggest that the assistants who are present just start their video so that everyone see their face. So Raphael is, yeah, perhaps I did forget to mention that Raphael is working on mainly waste treatment. So the way we can do the best usage of our waste for the benefit of the environment and the society. Is Xiang available?
Yes.
Yes.
Hello,
okay.
everybody.
Always in the sky. So Xiang is working on energy systems. So Jonas?
Yes, hello.
Hi, Jonas. So Jonas is, has just finished a master thesis with us, and he's starting a PhD. Up to now, his specialization is the website Energy Scope and modeling of the energy system in Switzerland and in Europe. So Alessio, are you also here? I was not sure if Alessio would connect this afternoon.
Yes, I'm here.
Hi,
hello, everyone.
Alessio. So Alessio is doing a PhD mainly on the way processes can be integrated into the grid with renewable energy. And then Yasmin.
Yes, hello.
Hi, Yasmin. So Yasmin is, and then Dia. Dia, are you there as well?
Hello. Hello.
Hi.
I have a problem with my webcam.
With your webcam, but we have a nice picture of you on my slide. So, so Dia and Yasmin are both master students in mechanical engineering. They have passed successfully the exam last year, so it means that they are also good reference for you if you have questions on the way to organize yourself or on the way to pass the exam, so they know how I'm going to ask questions. I think that they both have already passed 2 exams with me, so they know how I'm at the exam. Okay, so thank you very much for being here. And now let's start. Let's start by, let's imagine that you are an engineer and you have been hired as an engineer in a dairy. Very nice dairy process that is processing milk and then producing milk products, making profit out of it, hopefully. And your boss has been participating to a very nice conference, which was organized by all the shareholders of his company. So they were coming back from this, he's coming back from this meeting, and they were, he has been asked by the shareholders to evaluate some options. In the one hand, so those are the notes that the boss has taken. So there is a possibility that they have to pay a tax, or the shareholders would like to reduce the amount of tax. They would like also to increase their visibility and so become greener. And during the conference, they have been in contact with Rivela, because Rivela was asking them to buy whey, because Rivela is produced with whey. And one of the questions that raised there was that, so can we integrate the production of the milk together with the production of Rivela? The reason for this is that on the one hand, the byproduct of the milk production, which is the whey, can be used as a raw material for the revela production. But at the same time, if we convert the biogas into the whey into biogas, there are some people who are proposing now to separate the carbon dioxide from the biogas, which would allow to have as well carbon dioxide. And you know that a novel vision of or an integrated vision of a dairy that instead of just selling the whey could sell the waste heat, the whey, and the carbon dioxide in order to make another product that would be the revela. So now the question is open. So there are a lot of questions because perhaps it would allow to reduce the emissions, because if by treating the whey I'm producing biogas, then I will have green gas that I can substitute, that can substitute the fossil one that was used here. Okay, so it would allow me to reduce the carbon dioxide emissions. Perhaps I could even capture carbon dioxide there, so that I would have zero emission for this plant. But then we have also to answer the question, so do we just sell the whey, or do we integrate the production so that the dairy could perhaps have a good synergy with the revela production, but then also a competition perhaps with the biogas production. So do I have to produce more biogas or more revela? And of course, my stakeholders, so who are going to give me the money for doing this, well, they would like to maximize their profit. So they will sell together with revela. By making a deal, they will sell a new product, which will be the revela. But they also ask us to know if there are not more profitable products that could be considered. So, for example, why instead of producing simple milk, we could perhaps produce dry milk that could be then exported with a higher value. So this is what your boss is asking you to do. And okay, so the question is, as you are engineer, so what would you do? So what would be the action list? And for answering these action lists, what I would like you to do is that to use the chat. So you have a chat room, and Rafael is going, and I'm going to look at the chat as well. So I give you 5 minutes to write the list of actions you would have to do, or you think you have to do, in order to answer the questions of your boss. So I remind you the question. So what can I do to reduce the emissions? Is there an opportunity to integrate with the revela? Is there an opportunity for producing biogas and perhaps recovering the carbon dioxide for the revela production? And what is the best solution at the end? Okay, so I'll give you 5 minutes and write things in the chat. So don't be shy. I think that you have to figure out to imagine that you are in front of your boss. Okay, so you're a young engineer, freshly graduated, so like Jonas, and he's asking you to give an answer. And I hope that the answer will not be the silence, because you have been graduated from EPFL in the meantime. So you know how to write in a chat? You're right. So continue to write, and then I will make comments. Huh? So please propose solutions. So what are the steps? So what do you need to do? So it's a big silence. So you can clean the CO2, you can use the dairy emitted carbon dioxide and combine it with the biogas CO2 to make Rivola. Yes, you can clean the carbon dioxide. So what are compress the carbon dioxide? Other ideas? So don't forget that the question is, can we reduce the emission? Yeah, so you said that you need to an amount of you need to know the flows. Yeah, that's correct. So perhaps that the assistant can help a little bit, because otherwise. So are you sure that with a team of 30%, the boss will be happy to have only 3 answers? Okay, I give you 2 more minutes, but please try to find what you need to do, in fact. Okay, so typically when I'm in this situation, I'm waiting for the answers. Yes, it means that you need to have metrics that allows to measure the priority, to define the priorities. Okay, so I'm going to give you my answer. Yeah, so I think that something that is important here is that you can see that you are coming with flows, the need to know the flows. So I think that the first step we have to do is to know what is the current state. So we would like to know what is the energy bill, because we want to reduce the energy bill. So it means that it would make sense to know what is the energy bill. And this energy bill can be expressed per kilogram of product, which means that then we will know how much energy we need per unit of product. Something that would be also nice to know is the total amount of product produced over 1 year, and how much out of this production the energy is costing. Another dimension that would be nice would be to know what are the carbon dioxide emissions that we have and where they are. So it can be after the combustion, but it could also be in the way, indirectly in the way, coming together with the biomethane that could be produced. And perhaps something which is also important is to know what would be the impact of the carbon tax on the energy bill. Another dimension that would probably be important is to know how good we are. So it would make sense to know if the milk process that I have is consuming less or more than the competitors, because I need to know finally if I am good on the market, if the energy bill that I'm paying is the same as my competitors or higher or lower. And perhaps it would be also a good idea to know if I'm good in a thermodynamic way. So it means that if I'm able to understand what are the needs in terms of the thermodynamic transformation of raw milk into milk products, then I would be perhaps interested to know if this conversion is good or not. The second dimension is what are the options? So you have mentioned that there were some options that were related to clean the CO2, to capture the carbon dioxide. I think that it would make sense also to see if we can perhaps then first optimize or reduce the energy consumption of the process to verify that the waste is well managed, and that's what was related to the biogas production. But it would also then mean that we have to quantify what are the energy needs of the Rivela production as well. Okay, the energy and the material needs. Okay, so that I can then see if there is an opportunity to mix the two. And something which is important here is quantify the flows. And then for each of the options, what we will have to do is to speak about what are the energy needs. So in addition to the flows, the material flows, we will have to look at the energy needs. We will have to identify the synergies. So if the two processes are competing, for example, by using the way, or if they are in synergy one with the other, so it means that the waste heat of the waste material of one production can be used as a resource for another process. And something which is very important here is that we have to know what are the investments that are related. Okay, we will have to see how much we will have to invest. It means buying new equipments to recover heat, to convert heat, to link the processes, so pipes to link processes, even to buy equipments to operate the system, in such a way that at the end, I will be able to quantify what are the benefits, and the benefit for the stakeholders who are going to give me money to make investment, to connect the processes, hopefully. And I will have to show them that if they give me money, then they will have a benefit out of it, meaning that the energy bill will be reduced, perhaps that our image will be improved, and that we will be less affected by the CO2 tax. So this is, I guess, the first thing that we have to consider. So the most important dimensions here are defining the needs by characterizing flows, defining the current state, because I'm going to invest, it means that I'm going to mobilize capital in order to make something which is going to be a priori more profitable than the present situation. So it's very important then to characterize where we are, and afterwards, by comparing the options, identify where we will be, both from the energy side and from the investment side. Okay, so this is our goal. And now what we can say is that we have to analyze how we are going to do it. Okay, and what I'm going to explain you now is the way to do it, but not for the dairy and Rivela process, because you will be in charge of doing it during this semester, but more in a conceptual way. So when I have a process, typically I can see that the process is a set of process units that are going to convert raw materials into products. And typically, this is what I see from the, let's say, economical side. So I'm buying raw materials and I'm making products that I hopefully will give me some profit. And in reality, What I have to do is to look at what is happening inside the system. So I have to understand what are the steps, like the steps that are here, that are needed to transform the raw materials into the product. And what I have also to understand is what is the role of the energy in the system. So the first step is typically to look at the mass balance. So the mass balance is going to say that the mass that is entering the system has to leave the system. So we remember that the first principle of thermodynamics is telling us that there will be no losses in reality. So it means that the mass that is entering the system is going to leave the system, and the part that is not in the product will be available or will need to be treated as waste. And the waste is going to be needs to be characterized. So the first thing we will try to do is to look at what are the flows in terms of mass flows without forgetting any flow, because what is not ending into the product is going to end up as a waste, and most probably will appear as a tax when it is ending as a waste. The second dimension is the energy audits, and the energy audit means that we are going to see which kind of energy do we need and what are the operations that are used in order to the type of energy that is used in order to realize the process. So for example, we will have the electricity that will be used. The electricity will be used in pumps. It will be used also to mix things. It will be used to compress, to change the pressure of a gas. It can be also used to transport things inside the process. In addition to the electricity, there will be the heat. So heat is mainly used for process operation that needs to be that requires heat. Perhaps it is an evaporation. It can be also melting things. It can be drying as well. It can be a separation by distillation, but it can also concern chemical reactions that needs heat. In addition to this, then I will apply the energy balance. And the energy balance is going to tell me that the energy that has entered the system, either from the raw materials, from the electricity and the heat, can then be ending up in the outlet streams. And there are two types of outlet streams. On the one hand, it's the energy value of the product and the waste. So it means that with the mass balance, I have also the energy balance that is related to the product flows. But at the same time, I will have heat that will be released. And the energy balance is going to tell me that the energy that is not going to end in form of products or waste will have to be released in the environment. And this is typically what is happening when I'm using a heat exchanger to cool a flow, when I'm using a refrigeration cycle, when I'm using freezing, or when I'm condensing flow. So this defines, in fact, the mass and energy flows that I need to characterize when I'm doing the energy audit. Once I have this definition, then I will go into the next step, which is to look at the different process units and try to identify if the process units are first operating well, if they do not need to be better isolated, so insulated, so that I do not release heat in the environment for free. If I'm using the right one, so it means that I'm going to compare the technologies that I have in my process with the one that are in the state of the art in the industry. Perhaps I will identify new technologies that can do the same job with less energy. And I will also then try to optimize the operations. So perhaps I will try to make coordination between heating and cooling processes in such a way that I will be able to do a heat recovery, or also look at the possibility of doing energy management inside the system. So being smart in understanding the way the energy is used inside the different process units, and avoid, for example, heating a vessel that will be then afterwards directly cooled down. It's perhaps better to keep it warm for a longer time. Well, once I have done this efficiency analysis, then I will go into looking at trying to identify the possible heat recovery. And for doing this, I'm going to make an analysis of what is at which temperature I have to supply the heat in the process. So I'm going to create some sort of a temperature enthalpy profile of all the needs that I have in the processes that I have to supply with heat. And at the same time, I'm going to make the inventory of the temperature at which the heat has to be evacuated out of the process. Okay, and what I'm going to do now is to try to see if inside the system, by doing some investment, I can recover the heat of a stream that needs to be cooled down in order to preheat a stream that needs to be heated up. By doing this, I will define an investment that is related to this new, to realize the heat recovery. By doing the heat recovery, what you can see is that I will, due to the energy balance, I will reduce the amount of heat that is needed because I'm recovering some heat and therefore I will have to supply less heat to the process. And at the same time, as I'm using the heat of a stream that needed to be cooled down, I'm going to reduce the amount of heat that is released in the environment. Okay, so there will be a win-win situation because I'm going to reduce the amount of heat needed and I will reduce the amount of heat that needs to be evacuated. Once I will have identified all the opportunities for doing heat recovery, then I will go into another dimension, which is, let's look at the residual heat. That is the amount of heat that is leaving the system. And sometimes I will realize that some of the heat that is coming from, that needs to be evacuated is hot enough to enter or to evaporate a fluid that can be used in order to drive or to be used as a heat source in a heat pump that can then, after, by using an additional amount of electricity, produce a new amount of heat and therefore reduce the amount of heat that is needed by the process. At the same time, I could also be in a situation where the heat, the remaining heat has no value for the heat requirements, but can be converted because it has still a value in terms of temperature, can be converted into electricity by using, for example, a Rankine cycle that would use in the expansion of a turbine the waste heat available in the process to produce mechanical power. All those operations requires investment. So I have to invest heat exchangers. I will have to invest in a heat pumping cycle, meaning 2 heat exchangers and a compressor in order to satisfy the energy requirements of the process. But what you can see here is that by doing this, I'm reducing the amount of heat that is needed by the process, but at the same time, I'm also reducing the amount of heat that is released in the environment. Now, still, I have to ask myself, so how do I supply this heat? And this is especially what is going to happen when I'm looking at, I have an electricity need and a heat need. Sometimes what I will do is that I will provide the heat by using what we name a cogeneration unit. And the cogeneration unit is going to supply part of the electricity that we need and part of the heat that we need, or perhaps the overall amount of heat that is needed. This is what we name the combined heat and power integration. This can be done by engines. This can be done by steam cycles. This can be done by also heat pump integration. So at the end, we will have a complete system that will then allow us to define the fuel consumption. And the fuel consumption is going to give me an integrated vision about the conversion of raw materials into product and waste, because I have now the amount of energy that I have to buy in order to satisfy the needs of my process. Still here, you can see that I will have to buy fuel and perhaps balance with an additional amount of electricity that needs to be supplied. Now, something that is important here is that I still have heat available. And so the idea is that we have to ask ourselves if it is possible to use this waste heat. And one of the ideas would be to say, okay, is there something around me that can use this waste heat? So it could be another process. It could be a greenhouse, or it could be a city nearby. And at the same time, I will also ask myself, so what can I do with the waste? Is there a way to convert the waste into energy? Is there a way to convert the waste into a new raw material in order to make a new product and reduce, therefore, the amount of waste that is released in the environment by transforming a waste into a product? And this is what we name the industrial symbiosis, or the industrial ecology. We are going to make more products out of the raw materials, try to minimize the amount of waste that is generated, try to reuse the waste inside the system, and at the same time try to reuse at maximum the waste heat that we have. And at a certain time, we will have to realize that cities need also heat, and typically the cities are heated at around 20 degrees C, because it's the temperature that we need in buildings. And so by having a holistic approach where we can consider that we have industrial processes that are integrated one with the other, then we can have a very efficient use of the fuel and the electricity resources that are used in the system in such a way that we try to maximize the use of the energy and the value of this energy in such a way that we will minimize the amount of heat that is really released in the environment, and perhaps that we will use the buildings as the coolers of the industrial processes that we are investigating. So this is the concept of the advanced energetics approach. And my goal in this course is to finally be able to explain you how you can propose the solutions, meaning analyzing the energy requirements of industrial processes, identifying the best way of doing heat recovery, identifying the best way of doing the energy conversion, and making what we name the thermoeconomic evaluation of the solutions, meaning identify which are the investments to be done and what are the profitability of the investments to be done. Okay, so this was the first part of my presentation that shows a little bit all the steps that we are going to do in the course. Now I'm going to perhaps wait some 2 minutes to, if you have some questions, please use the chat if you have questions. Otherwise, I propose that I'm making just a 5-minute break, and afterwards I'm going to explain a little bit how we are going to, the course will be organized. So feel free to send questions in the chat, okay? It can also be more generic questions. Do not be shy in using the chat. Okay, so there are no questions. So what I'm proposing is that I'm making a short break of, let's say, 10 minutes. So we will start again in 10 past 3 with the explanation of the course. So I hope that you are all back. Now I'm going to give you the explanation about how we will be organized, and then Raphael is going to go into more details afterwards. So the course is organized, so we'll just remind you what is the goal. So the goal is that I would like you to learn how to analyze and improve industrial systems. So it means that I would like you to look at all the options that I have explained and be able to make the synthesis about the options that are available and give for those options what we name a thermoeconomic evaluation, meaning be able to assess what will be the investment needed and what will be the benefit of implementing the solutions that you would propose. So there is a part that is related to the analysis, a part that is related to your creativity, and a part that is related to the assessment of the different solutions that you might propose. So the course is organized with, let's say, 2 different dimensions. On the one hand, lectures, and the lectures are explained on Moodle. So the sequence is available on Moodle. Those lectures will be given remotely. In fact, you will have to look at videos and will not impose you the time at which you will have to look at the video. You will be free. However, something which is important is that for those one, we will organize the course into 3 big modules. And each module will have the following structure. So on the one hand, I will make a small introduction by giving you the context or the content of the videos. This will be quite short, and that will encourage you to look at the video. And the goal is that the video will present you the theory that you will apply by solving the case study. The case study will be the project that I have presented with the dairy process that will integrate the Rivella production and the biogas production. And then you will work with the teaching assistant in order to apply the theory and solve the project. And what the assistant has presented to you is documented examples that show how they have in the past solved a similar problem. So it means that you will have to look at the exercises that they are proposing, their corrections that they are also proposing, and then you will have to apply those into your specific project. You will have to write a report and prepare a presentation. From my side, during the weeks where you will prepare the presentations, I will be available in a flipped class mode. What does it mean? It means that I will be available and you will be invited to to propose time slots in which you would like me to come to your room in Zoom and answer your questions. Okay, so I will be available to answer your questions, but you will have to reserve the time slot. At the end of the module, you will have to make a presentation. So you will present what you have done, but in addition to presenting only what you have done, you will have to present the theory that is associated. And each group will receive a list of theory application questions they will have to develop during the presentation. So the students will then make the presentation. So you will make the presentation. you will show how the theory has been applied into your project, and then I will comment your results and your presentation. Something which will, what it means that you will be in a situation like when I'm asking questions at the exam. So I will give you the feedback on what you have presented, and I will show you the kind of questions that I'm asking when you will be doing the oral exam. Once this will be finished, then I will introduce the next module. So there will be 3 modules. The first module will concern the mass and energy balance. So how do we calculate the mass and energy balances of a given industrial process? The second step will be calculating the energy bills and the corresponding emissions. And afterwards, I will ask you to analyze the exergy efficiency, so the thermodynamic efficiency of the different process units in the system under evaluation. This will be the first module. The second module will deal with the thermoeconomic analysis. So how do we estimate an investment? How do we define afterwards the total cost, so the compromise between the energy bill and the investment that needs to be realized? How we analyze processes in order to define what are the energy needs of a process, and how do we identify heat recovery options in processes. This will be the second module. And the third module will be concerning the definition of the investment related to the heat recovery that you have identified, to the investment related to the best way of converting the energy that you buy into the energy that is needed by the processes, to finally, at the end, be able to compare and to make the assessment of the different solutions. So depending on the number of students registered in the project, you will be working on the applications in groups. So the groups will be typically, if they are, depending on the size, if there are more than 3, then we will propose to divide the groups into subgroups who will be responsible of evaluating different options. You will be offered weekly meetings with the supervisor and the TA. So this will be organized online, but also in presence if possible. And after the period of the semester, you will have to deliver a report. So Rafael is going to explain all the methods for preparing reports, etc. And then you will present, okay, it's not 6, but 3 modules, and we will, it will be like the exam. At the day of the exam, you will have then to present what you have done, and especially how you have done it, so how you have applied the theory in the project, and you will have to answer my questions. So the project is really the basis for preparing the project, for realizing the project and for applying the theory. So normally at the end of the project, you will be able to answer the questions and illustrate the theory, the application of the theory on a real example. So the goal of the case study is to apply the theory on a real scale, which is my first goal, because I will use this as a proof that you understand the theory and that you can apply it. But at the same time, I would like to teach you some, what we name the transversal skills. On the one hand, to write a report that needs to be clear, concise, that needs to be written in such a way that it can be read by other people. There are guidelines that are offered, and Rafael are going to present those guidelines. And we also propose to use professional tools like Overleaf that allows to do scientific writing, applying tools or developing a document within a group. In the second transversal skill that I would like you to learn is how to present results. you will have to make presentations, you will have to defend your assumptions and present your assumptions, and you will have to explain how you have solved the problem. So it's not just a question of presenting results, but also to put them in the perspective on how to do it and why it is important. And at the end, so this project allows you as well to, will also allow you to apply some tools that we are going to offer to you. And at the end, we will use the case study as support for the exam. So you will have to summarize what you have done using a poster, and then you have to present this poster, and it will serve as a support for the discussion of the application of the theory. So this gives me then the presentation, the definition of the oral exam. So the oral exam is mainly the way to get the credits. It is a priori around 20 minutes per person. It's an oral exam. You will have to present a summary of your case study with the methodologies that have been applied, and you have 3 minutes to do it. And then afterwards, I'm going to ask you questions to verify that you are mastering the skills that I would like you to know. Once you will be finished with the oral exam, I will start my own exam, because I will ask you to fill a detailed evaluation form about the course. The exam grading will be mainly related to individual things that you have done. It will be based on your oral exam for 40 over 60 points. But there will be a small amount given to the case study, to the quality of the report and what you have done, as well as another individual assignment that you will receive in the middle of the semester. In order that you are not surprised by the questions, I'm giving you the list of questions. And the list of questions this year will be even more important. The reason for this is that I will ask you to answer the questions when you present you make your presentation. So each group that has to present the results will have to develop the theory that has been applied, and it means that it will allow you to have a predefined or prepared answers by different students and comments from my side during the whole semester. So the last remark is that perhaps just a feedback from the students' evaluations from the previous years. So sometimes we receive an information that the slides are not clean and clear. So I would like to highlight the fact that you have lecture notes, you have videos, and of course the slides are mainly there to support what I'm saying. It means that they cannot be used as lecture notes. Sometimes some people are complaining about the fact that the lecture notes are not well organized. We have tried our best to make a well consistent document, but you will have to accept that sometimes there are some I'm not always, the lecture notes are not always following the same sequence of the course, because we have organized the course to solve the problem and not only for presenting the theory. Concerning the examination methods, I would say that I'm quite confident that I'm fair with the method that I'm using for doing the evaluation. You can ask the students who have attended my exam in the past. In fact, the most important part is that I'm confident that it's a very good way of assessing what I want you to know and to have learned. So this is why I'm quite sure that this method is quite efficient. The course is difficult for students who do not have a thermodynamic background. Okay, so this is true. And it means also, it explains why we take sometimes in the beginning of the semester to allow everyone to catch up. If you have difficulties, it will be mainly during the first weeks. And I will really encourage you that if you are not feeling comfortable during the first weeks, to ask questions. So we are there to help. We can explain and spend more time to explain things that are not clear to you. So it means that the first weeks will be critical. Okay. Concerning the project, I would just like to mention that it is a new way. So it's a project-based learning. It's not exercise and corrections. Okay, so it means that you will be asked to take a lot of decisions by yourself. And one of the reasons for which I'm doing this is mainly because I don't want you to continue to do exercise with numbers that I have prepared and with answers that are already known. Okay, so it means that part of the work is to structure the way to solve problems and not only follow instructions. So it can be disturbing because it's perhaps the first time you are facing this kind of approach, but I'm quite convinced that this is much more efficient than just giving you exercises and corrections. And the last remark is related to the office hours. So in this case, because we are going to work online, there will be office hours that will be fixed by the TA. They will give you their own availability, and there is always a flexibility. It means that if a group has courses at the time where the TA are declaring their availability, I'm sure that they will be happy to change to be sure that you will be satisfied and well coached by the TA. So I have an email, do not hesitate to use it. I would prefer that you send the question and answers, the questions via Mattermost, and Raphael is going to explain you how to register on Mattermost. So to conclude this presentation, I would like just to highlight why is it important to work with the advanced energetic approach. Industry, and this is the word picture of the energy. Industry corresponds to 29% of the energy consumption of the world. It is also highly related to the use of electricity, which is creating a big burden in terms of carbon dioxide emissions. And when I'm talking about synergies, I have also shown that the waste heat of the industry can be used to heat buildings and services. And so what we can see is that at the end, the energy or the industrial energy systems corresponds to, let's say, 2/3 of the energy consumption of the world. And when I'm saying 2/3, it's mainly because the waste of the fuel production that is used for the transportation is typically used in industrial processes to make products, which are carbon-based products. And therefore, the energetics of industrial systems is a key element for understanding the energy use in the world. So to give you an order of magnitude, the total amount of oil that is consumed in a second is the equivalent of 10 tanker trucks per second. Okay, and out of those 10 tankers, 3 are used for products and 1 are directly used for the industry. So per second in the world. In addition, you have the gas that is used, and 20% of the industrial heat is supplied by burning gas, and the electricity is produced 44% by 44% of the electricity is produced by gas as well. The coal is 44% of the gas is used by to produce electricity. The ratio for the coal is a little bit different, because still there are a lot of heat that is supplied by the coal, but of course a majority of the use of the coal is to produce electricity that is at the end mainly produced by fossil-based resources. 75% of the electricity is fossil-based, and with at the end a low efficiency. When we look at the energy usage in the industry, we can see that the industry is consuming around 1/3, a lot in form of heat, part in form of electricity, and a very low amount in form of renewables. So you can see that the 27% is in form of electricity. Then you have gas, coal, and oil that is supplying the rest of the energy needs, and only 7% is coming from the biomass. If I'm looking at in Switzerland, so Switzerland is not an industrialized country in the sense that we prefer to ask the others to produce for us, but nevertheless, 20% of the final energy consumption is in the industry, and in those 20%, 56% is in form of heat, and 44% is in form of electricity. So what are the meaning of the industry? So the industry can be the chemical industry, so the fertilizers, the production of fine chemicals, the production of additives. The pharmaceutical industry, which has a big share in Switzerland, which is typically associated to the chemistry, that is producing drugs, that is producing vaccines, hopefully, and that is also needing a lot of clean rooms, that needs a lot of energy to be cleaned, where the air needs to be cleaned. But it's also the cement industry, it's the petrochemical industry, so everyone who is producing gasoline, diesel, kerosene, but also plastics. The steel industry and the metal industry, but it's also the food and agro. The application we are going to study is a food and agro applications. But you can also consider that manufacturing a car, manufacturing a battery is an industrial process, the way as the power production and the waste management. If I have to do an incineration, if I have to recycle waste, if I have to sort waste, it's an industrial processes. And at the end, if I'm looking at the full system picture, even urban systems can be treated as industrial processes. This is the repartition of the energy consumption in the different sectors in Switzerland, with the major energy consumption being in the chemistry, fine chemicals, and pharma, then the food and agro, and then afterwards it's the watch industry and the cement industry, with a big difference is that sometimes, for example, for the watch industry, the use of electricity is much bigger than the use of heat. So this is for the different sectors. And when I'm looking at the overall energy system, this is the goal. So on the one hand, you have the present energy consumption that is calculated, and this is an extract of the energy scope platform. So the total energy needs in Switzerland and the goals that the government has set. And in the goals, the industry has to reduce by 30% the amount of heat that it is going to need to consume, and by 36% the electricity. And what is then becoming a problem for the industry? The problem for the industry is that at the same time, they would like to increase their revenue. And it means that they have a trend to increase the amount of product that is produced. So the production is going to increase. And if I want, and this is because I would like to have more revenues, and if I want to reduce the amount of energy that is needed, then I will have to reduce even more the amount of the energy intensity, so the megajoule per kilogram that is consumed. And what is interesting, and what you can see in this curve, is that this works in Europe. Although the production, the chemical production has increased, and you can see it, the amount of production, so the amount of product that is produced in Europe, the energy consumption has decreased, which means that the energy intensity, so the consumption per unit of product, has drastically been reduced. And this is important because we are facing a big problem. So the carbon dioxide emissions. So I will not just present this. I will just remind you that today there are big problems in California because there are fires everywhere due to the climate change. There are other problems coming from a lot of floods and inundation, floodings that are happening, and even places in the world in which the people will not be allowed to live anymore. So in the Dutch desert, they have been reaching 51 degrees C this summer, and this is a temperature at which the people cannot live anymore. So we have to solve the problem, and this is the responsibility of engineers. I'm sure that Trump, if you show him that you have a solution that is cheaper, that is using less resources, and that is creating jobs, he will be happy to do it. So the industry is going to play a key role. The industry has played already a very important role in the carbon dioxide emissions. Carbon dioxide is a key, is really a key element, and the carbon dioxide intensity is perhaps even more important than the efficiency. But what we can see, and this is a result from the International Energy Agency, is that if you combine the efficient use of the energy and the fuel switching, especially using renewable energy resources, then you can see that you will be able to reduce the carbon dioxide emissions to a level that is going to be near zero in a near future. So now the floor is yours, because this will be your job to be able to reduce, to apply the efficiency measures in the industry, to identify the solutions, and to integrate the renewable energy resources, or even the capture inside industrial processes. So by this, I'm finishing, and I'm going perhaps then to give the floor to Raphael, who is going to present in more detail how we will be organized. I don't know if you have questions, so please feel free to send questions to the chat still, okay? And I directly propose that we switch to Raphael, yeah.
Hello, can you see my screen properly?
Yes.
Yes. Perfect. Okay, so let's start. So as Francois said, so this is our our team. It's me, Xiang, Jonas, Alessio, Dia, and Yasmin. You can also check our website, the IP's website, to search for projects or what we are doing, open positions. Can be interesting for you. So let's start for some general instructions. As Francois said, all the rules are already in Moodle and they are available 24/7. Although we would like, we are not available 24/7. So you could count on us on Mondays on the normal scheduled time, and also on Fridays. That is our our day to do some office hours that are spread across the day. As Francois also said, we will have 3 components of evaluations. So 10 points that are attributed individually for a review of a project of last year, 10 points for your project classification, and 40 points for your oral examination. Of course, the 60 points corresponds to a 6 at the PFL scale, and will be converted linearly to the respective mark for the other grades. So Moodle contains the full plan of our next 13 weeks together. It is important to understand this mechanism of videos, exercise, and projects that I'm going to explain a little bit better right now. So the logic is something like this. So we have videos that are available 24/7. Please don't leave it to the last day. We have notes and books that are also available 24/7. And from day one, so you have already on Moodle everything you need. We have exercise and we have the resolution of the exercise. So not only a solution, a resolution, and also a video explaining how we thought about it and how we solved the problem. And then you have your project. The projects are already online, but the groups are not attributed. I will go through it a little bit better. Each group will also have an overleaf and a Mattermost channel. So let's go to the blocks. We have 3 main blocks, as Francois also explained. Block B1, B2, and B3, and they correspond to a specific task on the project descriptions that are the same for every group. Each block will last approximately 4 weeks, and it comprises everything: the videos, the exercise, the lecture notes, and all the information that you can find. And each block is also a presentation. We did this in such a way that the groups can be presentially on campus before, at least the EPFL COVID groups can be on campus before the presentation. So this year, contrary to previous years, the groups will be formed by us. So we are still waiting the final IS Academy enrollment. So up to now we have 44 participants enrolled in Moodle. But there is still people that can drop and people that can enroll. So we are still waiting to form the groups. So this is an example of a distribution based on a random student distribution. So we would have, for example, group 1 and 2 as a group A of COVID, 3 and 4 and 5 as B, and the group C with a group 6 of advanced energetics. So the project, each group has a project assigned and they are all with a similar degree of difficulty. So, I mean, it is random how it is attributed. It is a simplified version of an industrial process. Some assumptions are provided, but other are not. And this is an important, and it is important to highlight. So at a certain point, so after the mass and energy balance, that we can tell you if it is correct or if it is not correct. Some economic or environmental assessment, we can actually not. So you will find the costs, and if they are from good references, and if they are valid, your result will be also valid. It is important, what is important from our side is that you search for good references, that you manage to solve the problem, to present good solutions to the company that you are fictitiously working to. So we are here to help you. So make sure that your mass and energy balance are closed. This is important, huh? And each group will be assigned 2 teaching assistants. This avoids the overlapping on Fridays that you might have, and it also as an increased number of TAs allow you to ask questions and for them to be answered more efficiently. Groups are expected to work on the project on a weekly basis, and this is really important because only one of the COVID groups will be on campus, but we expect the others to be working, and we are available to help you on that time. So the project description, as well as Francois said, so there is a pasteurization section, there is an evaporization section, there is a special section, So some of them will produce mozzarella, some other produce cheese, some other ice cream. And there is also a wastewater treatment and a dairy sludge production. And also your industrial, so the guy that will hire your group went to this roundtable conference discussion, and he met Mr. Rivelli and Mrs. Green. One of them tells him, why don't you take the whey, the lactose serum, and produce some Rivella? While the other tells you, okay, take the sludge, and also you can take it away, produce some biogas. And so you are asked to assess both solutions. So this is the big question, assess both solutions from a thermodynamic, economic, and environmental perspective. If you notice here, we have some biogas that you could eventually upgrade. So the approach that was suggested by Francois. So exactly what I said. So by the end of the semester, you should be able to give an answer. And how can we give an answer? We have to answer several things. We have to answer the why, the what, the when, the who, the how. So you have to completely characterize your process. And most probably what you will reach is something like this. It's a Pareto front. So you will have a trade-off between investment costs and operating ones. And we'll also have some environmental impact associated. In the end, we'll provide our decision maker, the person that hired us, with a set of solutions that they can then make an informed choice. And this is really the point, is to give information to decision makers. Our availability, again, we are available on Mondays from 2 to 7 p.m. Office hours are available on Fridays across the day, depending on the TA. I will put the schedule really soon on Moodle. To book a session on Friday, and this is important, you should inform by the mattermost that you are at least one day before that you want to meet. You should provide a list of questions and doubts that you'd like to discuss. So it's not a cafe discussion, so you should have an agenda. You should want to discuss a specific topic, and we are open to do it. A priori, you should contact your reference TAs. Although, I mean, of course, all of us are available. From Francois' side, so the Monday before each block presentation, there will be a Zoom meeting with each group individually to answer a list of questions. Francois already explained this detail, but it will be also on Moodle and very soon. Presentations, 3 presentations. So the first one on the 19th of October for EPFL Group B, the second one on the 16th of November for Group A, the third one on the 14th of December for Group C. Each group will present at least once on campus. Each group and for each block, you will have specific questions assigned. So you can also, you can already find it on Moodle. On the day of the presentation, there is a list of questions per block. The presentation will be recorded and streamed, as well as questions and feedback. And we want you to include some stuff. So you have to state your assumptions, your methodology, and your results obtained. And here, please justify and provide the references of where you took the values from. Be critical of your results. So for some years, we find groups that present negative investment costs, or I don't know, I mean, random things appear from nowhere. Drawing conclusions and discuss them, and we are here to help and not really to judge. Presentations, why is it important? It is important because it trains your soft skills and you learn how to present your achievements. You should be concise and clear on how to do it. You will also learn how to receive and provide feedback. And companies, of course, one day most of you will work on a company, and they love very good presentations. Some hints, so if you have time, and I think you will have it, define a template for your presentation. Don't do like loose slides. Make sure you have numbers on your slides. The font is is good enough for everyone to read. Your plots must be understandable, and train your presentations. Okay, there is nothing as too much training on the presentation. So before your class, watch the videos, read the lecture notes and books that are available if you need. Do the corresponding exercise and check the corrections and note your doubts. There are exercises available, as I've said. They have guidance and a resolution. It is important, and it is important because we structure the classes so that for students that are already prepared. So you must not come to the class without seeing the videos, without getting informed on what we are talking about. This is particularly relevant for people that don't have a background on thermodynamics or mechanical or chemical engineering. For them, as Francois said, the 2 first weeks are crucial, and we are here to help. So if some of you are from, I don't know, civil engineering or architecture, I don't know, do come to me and tell me, well, I have some doubts, can you provide some extra references, or what do you advise me to do more in specific? I will be glad to help you. So during the class, you will have time to ask your questions. You should update your overleaf project as the project is updated. This is particularly important as well, as we want your report to be done with the semester. So by the end of the semester, on the 14th of December, our last class, you should have your report almost done. So the structure is everything there, and actually your presentations will come from overleaf. So you have all your data, everything you need there. We also think you have time for everything that we are asking, as you will be on average 6 elements times 5 hours, which makes 30 hours of work per week, per group, which is quite reasonable. After class, Monday at 7, Advanced Energetics is ready. Make sure your overleaf is updated. Invest on collaborative work, so really distribute tasks and put a deadline to have them. If you have doubts, use Mattermost or leave a note on overleaf. So this brings me to the tools. So overleaf, we will create them, both overleaf and Mattermost, as soon as we have the groups formed. You will be assigned 2 TAs. Overleaf has some really nice features, like track changes very easily. You can connect to your Dropbox. You can even get to Git. On Mattermost, we will have a general forum that is open to everyone, where Francois will be involved. So if you want to ask a general question, or if we need to provide a general feedback, we will do it on a general forum. But we'll also have a chat. It is important because then you can feel, you don't need to have to be ashamed of asking questions and dropping comments on the project. So in summary, you will have 3 blocks, 3 presentations, and 3 evaluation parameters. This presentation will be available on Moodle in approximately 10 to 15 minutes. I wish you very good luck, and we are open to questions if you need, or if you want to highlight or to éclairer something, please feel free.
Okay, thank you, Rafael. Yeah, so either you ask questions directly by unmuting yourself, or you can ask questions in the chat. So I think that it was so clear that there is no question. So I hope that this is my good interpretation. So I have one question here.
Yes.
On the groups by ourselves. So the answer is, as soon as we know who is registered in the course, then we will be in a position of knowing who will be in group A, B, and C, and we would like to try to maximize that the people who are in the same group can be on the campus at the same time. So this is a constraint that we will have to manage, meaning that we will impose, at least to some extent, the groups. However, if you are in if you know people who are in the same EPFL COVID group and as you, and you would like to work with, then please inform us. Then there is another question concerning how long should usually a presentation last. So my experience is that I'm asking around 15 minutes, because typically I'm going to speak half an hour for each of the presentation, because I'm going to give you feedbacks, to give you comments, to give you additional remarks on the application of the theory.
The instructions for the presentations are also on Moodle.
Okay, are there other questions? No, it seems that there are no other questions. So now what I'm proposing is to have a 10-minute break. And after the break, I'm just going to make a very short introduction of the two videos that you will have to, the 2 or 3 videos that you will have to look at for preparing the first block presentation and the related questions. So we start again at, so I said 10, or let's say 15 minutes. So we start again at 10 past 4. And after this, I guess that it will not take more than 15 minutes to present the two video systems, the two videos. Okay, so
I would also ask, would like to add, there is a problem, it seems, with IS Academia in registering for the course. I think it's a general problem because it crashed today. So up to now, we have 44 people enrolled in Moodle, but can be people still enrolling, still quitting. So we are waiting. IS Academia should be solved today, tomorrow.
Yeah, and so nevertheless, so what I'm proposing is that as we do not have lectures next week, because it's an official holiday, then it will give us some time to create the groups. Okay, so I'm going to mute myself and we start again at 10 past 4.
Sorry, I got fresh news. So IS Academia is back and they can enroll and quit until next Friday. So Friday the 18th, it is closed. On Monday the 21st, we announce the groups.
Okay, perfect. So let's start again.
Francois, there is a question about the review. Do you want
Yes.
to explain or you do it?
Yes, you can answer. We can answer. So let me just see.
It's in the chat.
Right. Yeah. So just for your information, there is when you write a report, in fact, typically you do not know what is the content of the report. And something that you have to do finally is to figure out what is what you will have to put in the report. And so what we have taught here is that instead of leaving you in a completely guided mode, so what we would like to do is to propose you reports that have been written last year about a similar subject, and for which we are going to ask you for making a review. So it means that what you will do is that you will read the report and send us 2 or 3 pages of things that are not clear to you in the report or questions that have been raised in the report. And this would be considered as being first an individual work, because everyone can work individually to give this review, and this will has to be considered as if you have to do a review of a paper that is submitted to a journal. So it means that you read the paper and then you make the list of all the things that are not clear to you, that would need clarification, or you explain what you have been trying to understand or what is missing, so that at the end you will have an individual report based on a previous report from the previous years. And this will be also used by yourself to figure out what you have to write in your own report, because of course you will see that things are missing, that things are not clear, and when you will write your own report, then you will try to do better than the people from the previous years. So from my side, so this is the goal, and the idea is that as this will be individual, so if everyone will have to write this small 3-page review. This will be part of your final grade, because this is an individual work to be done. I hope that it answers to the question. Okay, so let's go into, in fact, the work. What I'm going to do now is just to explain what you will see in the videos. So it's a very short summary of the videos, with at the end of each, so there will be 2 small presentations. At the end of each of the presentation, there will be the list of questions that you will have to answer if you are in the block 1 for the first module. Okay. So the goal of the first module is to help you analyze the energy consumption of a process, apply mass and energy balance, and calculate energy bills. So what you will learn is that the process is a system that is converting raw materials into energy services and products and byproducts. For this, the system is using energy and support materials, is going to produce waste, solid waste, water, or emissions plus heat losses, and is made by assembling a list of process units that realize the process. And what you will learn in the video is the steps that you have to follow, which is mainly based on recommendation from ISO norms, in which you will learn how to analyze the energy consumption, looking at the energy sources, the energy consumption strengths, and the baseline, identifying area where the energy is significantly used. So sometimes there are processes that do not use, or sub-processes that do not use a lot of energy. Define the energy performance, so the energy needs and the performance indicators, to finally identify where to look when you are analyzing the energy of a process. For doing this, then you will have to analyze the process starting from the black box, which is really what you see from the outside, define the system boundaries and the energy baseline, identify how the energy is converted, collect the information in order to be able to identify where the energy is consumed, to finally obtain a consistent data set of the requirements of the system, which allows them to define the key performance indicators. And then you will go into the reverse side, or the reverse flow, by identifying what are the needs, and then allowing you to go into identifying energy saving options and calculate what could be the energy bill in the future. So this is a bottom-up approach. So you have a top-down, starting from the bill, going to the process, and then from the process going back to the bill and give recommendations. when you look at the energy baselines, you will learn how to analyze the different type of energy flows that are involved into the processes. You will learn that the processes are not always operated in constant mode, but they can be operated in different production modes, and how the measurements of the process can be used in order to identify what are the energy needs in the system. And from there, you will be able to define what is the energy baseline, which is characterized by flows, it means productions mainly, by cost, because you have to relate the flows to the specific cost to have the total cost, which is indeed an integral. The same for the energy flows that are concerned, and as well the exergy that I will comment later on. You will see that there are really important dimensions coming from the thermodynamics, like the mass and the energy balances that needs to be applied, that are still some assumptions to be made in order to be able to understand what is happening inside the system and to characterize at the end where and how the energy is used, to be able afterwards to characterize the cost that could be the total cost or the specific cost, and which are always the integral, which is the sum of the energy use of the different types of use of the different types of fuels, and the multiplied by the time during which the production is really operating. So it will allow us to have the specific cost and the per unit of products, for example, or per unit of money. And then afterwards, you will also see some sort of a Sankey diagram that allows to understand where the energy that you buy is finally used in the project in the process, and for which purpose. And you will most of the time identify, see methods to identify the errors and the losses corresponding. So it means that you will look at the data available, identify who is consuming the heat, for which purpose and at which temperature, to finally identify who is important in the process. And you will learn that there are some systematic rules that allows to identify who is the most important or who are the most important. And there will be a focus on the needs and on the opportunities. So the needs is the streams to be heated, and the opportunities, the streams to be cooled down. And you will be also then, there will be also discussions about what are the key performance indicators that you have to apply in such a way that you will be able to identify the different elements in energy consuming units in the process, and how you can characterize the way they use energy and if they are important or not. With respect to the questions that you will have to answer there, there will be questions related to the mass and energy balances. So for example, you will have to be able to explain how you calculate energy and mass balances of process units in a flow sheet, explain what is the meaning of the assumptions made for modeling processes. So for example, the steady state operation, explain the use of a Sankey diagram to understand the energy flows, explain the heat and mass balances of mixers and splitters, what is happening when pressure changes, concentration or phase changes. The same for the heat exchangers, being able to plot the hot and cold streams in a heat exchanger, define and explain the minimum temperature difference in a heat exchanger, explain the energy balances of a heat exchanger, and the same for evaporators, and how the thermodynamic can be used inside to model the demands of an evaporator. And then you will be asked to explain how to calculate the operating cost of a refrigeration cycle, of a boiler, or of the heat supply to a system using steam. Explain how to calculate the operating cost of a process, and how to calculate the CO2, the impact of a CO2 tax on a process. So All the videos are available on Moodle. I will not repeat it, but you will find those videos on Moodle. This is for the first part. There will be a second part, which is then related to exergy. Typically, when I'm in class with exergy, I'm asking, do you know what is the exergy? So I always recall the energy balance, and then I remind that there is also the second principle, which is quantifying the entropy creation inside a process, and that by combining the entropy creation and the energy balance and deciding a reference state, then it's possible to define what is the exergy. The exergy being the maximum work that can be produced by a process, an energy conversion that could have been produced. And by making a balance, then we are able to identify what is the exergy loss. So what we can see here, there are elements that depends on heat load and elements that depends on mass flows, which means that we have to understand what is the enthalpy and what is the entropy that is concerned. So once you will have this, then you will be able to define what is the exergy, which is related to the maximum amount of work that can be produced from a state or by a transformation, by doing only reversible processes that can exchange only with the environment. So this is the definition, and you will learn what it means. You will also learn that the environment is not only the thermal environment, but it's also the pressure, the composition, and the material flows. There will be a discussion about the exergy value of heat that is released by cooling a stream, which allows you to have an idea of what is the amount of electricity that you could produce. And as the system is reversible, you will be also able to calculate how much electricity is needed to heat a stream. And you will also learn how to represent the transformation, the exergy transformation and the exergy losses when you convert fuel, for example, into heat and electricity, to identify where you lose the exergy and where and how to calculate those flows, to allow you at the end to make a calculation of the exergy efficiency, which is the ratio between the exergy that is consumed and the exergy that is delivered, which creates a good link with the losses in the system. Okay. And finally, you will learn about the calculation of exergy losses, and especially exergy losses that occur in heat exchange. When you exchange, when you heat a stream, when you recover heat in a heat exchanger, or when you release heat in the environment. And you will see that the exergy can be lost in different ways. In the process unit operations itself, in the conversion from the energy that you buy into the energy that you need, and from the energy that you will release from the process to the ambient conditions, like, for example, the heat that is available in the combustion gases, in the hot water that is released, or the steam that is vented. The questions that I might ask when I will be at the exam and that you will have to explain during your presentations are the following. You will have to be able to explain what is the exergy and how exergy balances can be formulated. Explain the different types of exergy losses, being thermal, physical, or chemical. Explain and demonstrate what are the exergy losses and characterize those exergy losses, especially for a heat exchanger. Define the exergy losses in a splitter or in a mixer, and define the exergy efficiency of a refrigeration cycle. So we look at a full system and explain where are the different losses in this kind of systems. And finally, explain how you can draw a Sankey diagram for explaining the exergy, or for realizing the exergy analysis of a process unit. Again, those videos and the corresponding slides are available on Moodle. There was a question about, I couldn't find the slides, but Raphael has already been answering. Do not hesitate to make remarks. So if you do not find something, if something is not clear, if you need more advice, so don't hesitate to ask. For us, it's quite difficult to give online lectures, and must admit that if I have not your faces in front of me, it's always difficult to see if I'm impacting or not, and if you do understand, so do not hesitate to use the chat to give me also a feedback. Yes, and the second answer is yes. So the question is, will it be presented again during the 12-16 of October? The answer is not. No, I'm not going to present the videos, because you have the videos that are available, but I will be available to answer all the questions that you have after you have been looking at the video, and when you have to present, to prepare the presentation. So it's 1 week before the presentation. So it means that if you are prepared in advance, so I will be there to give you a feedback of what you have prepared, and to help you give good answers in the presentation. So all the questions that will arise when you will present the presentation, I will be there to give you the answers. So I hope that it was clear. So I repeat, so the week before, as you have to prepare a presentation and then do a project, the part that is related to the theory, I will be available to give you a feedback on what you want to present, on answering the questions. So I will be the one who will answer the questions, and officially the week after, you will be the one who will answer my questions. Yes, so as there are 3 modules that concern, so sorry, I have to repeat the question first. So it's concerning the project organization. All the groups do a project which includes the 3 modules, but only certain groups will present their project, and that's true. So the one that are in the beginning will present only the beginning of the project. The other one will make it later on. Nevertheless, we have decided that we will do the following. The one who are not going to present will be selected randomly to ask questions. So it means that you will have, as you are doing similar projects, when you will see the presentation of your colleagues, there will be questions because perhaps you have not done exactly the same approach or not used the same assumptions. And what I will do together with LTA is that we will make a random selection of the groups or the people from the groups to ask questions to the group that is presenting. And this is before I am going to give my feedback, meaning that you will nevertheless have to be ready to compare what is presented by your colleagues and what you would have presented, so that you can ask questions. Are there other questions? So if not, I'm going to close this lecture. So have a nice evening. You know that you can start looking at the videos, collecting the questions, asking me the questions already. You have already the list of questions to be answered. so you can start preparing those questions. The groups will be formed as soon as ES Academia has the list of people and that we know who is in which COVID group. The TA will be there to help. If you have preferences for the group formations, do not hesitate to ask, to mention those to Raphael. Okay, so do you have other questions, or can we stop the presentation? So I'm stopping my screen share and go to the gallery view to see if someone has still a question. Otherwise, I hope that you will enjoy the course and that all the presentations were quite clear today. Have a nice evening then.
Thank you very much. Just a question,
Yes.
but it's for tomorrow for the course of life cycle assessment.
Yes.
We don't have any information on the Moodle, and I just wanted to ask if we have the course tomorrow and
Yes, the course